All right, today we're going to complete section 3. We're going to go over really quickly the sections 4, 5, and 6, which are addition, subtraction, multiplication, division. We've been doing that all along, but we'll go over, retouch on all the high points on that. Then we'll go to section 7 and 8 and finish up the chapter this week. So, section 3. This is of chapter 11. Deals with real numbers and the number line. What we have to first define is, what do we mean by real numbers? There are two types of numbers in our numeric system. There are real and there are imaginary. Real numbers are numbers that could be graphed. Imaginary numbers are numbers that cannot be graphed or cannot be ever achieved. They're just numbers. Imaginary numbers are like, but the square root of -1. It's impossible to get square root of -1, so that's why we give it the letter I to mean imaginary. The real numbers, on the other hand, are made up by a whole bunch of subsets. First type we call natural numbers. A natural number, another name for those, are called the counting numbers. When you're asked to count, you always start off at 1, 2, 3, and so on and so forth, all the way to infinity. So those are the counting numbers. Then we reach a form of numbers called whole numbers. Whole numbers are simply the natural numbers plus the number 0. It starts off with a whole. Then it goes on 1, 2, 3, and so on and so forth. So whole numbers begin with 0, which is the whole, and it goes on from there to infinity. Okay, so in a number line, we know there are 3 parts. There's 0, it's in the middle, and then we have numbers to the right of it, which are positives. These are the positive numbers. And then to the left, we have the negative numbers. Once we introduce the negative numbers, we now have the number system called the integers. Positive, negative, and 0. All right. Now we're going to another set of numbers. that are called the rational numbers. Rational numbers, the first 5 letters of rational is ratio. These are fractions. Every number can be written as a fraction. Two over 3 is a fraction. -5/7 is a fraction. 8/3 is a fraction. It's an improper fraction, but it's a fraction. 6 is a fraction. It's a rational number because every number can be divided by 1. Now, another type of rational are called irrational numbers. Irrational means not rational. Basically, that's how they're defined. They're not rational. Numbers. What separates the two is how they're written. Rational numbers fit in one of two conditions. The decimals are terminating or repeating. In rational numbers, the decimals are either terminating or repeating. Those are the two conditions. Let's see what we mean by terminating. If it's terminating, there's a last digit. It has an end. Repeating is just that. It's repeating. It's either could be a same number that's repeating or a pattern that's repeating. 2, 5, 2, 5. So you can guess what the next two numbers are going to be. 2, 5, 2, 5, 2, 5. If the number is repeating, if the pattern is repeating, for example, like if we had 0.333 and so on and so forever, instead of writing all that, we would simply write 0.3 with a bar over it. That bar represents that that number is repeated infinitely. 0.25, 25, 25, and so on. Since it's 25 that's repeating, you'd put the bar over 25. So it tells, that bar tells you what numbers are in the pattern that's repeating. So those are all rational numbers. The decimal is either terminating, it has an end, or it's repeating, has a pattern that's repeating. If it doesn't do that, then it's irrational. In other words, it has an infinite number of decimal places that there's no set pattern to it. For example, like pi. There is no set pattern and there's no end to that number. Okay. So these are the types of numbers. These are all the real numbers. Again, and then we have the imaginary numbers. And those are imaginary numbers, like things that cannot be actually solved. If the square root of -4, since it has a negative inside there, we know what the square root of 4 is. That's 2. But because there's a negative in there, it makes it imaginary. We can't graph it. And for imaginary numbers, remember we talked about that. Did you ever see this before? This is called a complex number. That's a number, that's every number. It's written in a real part and an imaginary. That's a complex number. It has both a real part and an imaginary part. A and B can be zeros or any integer or any number. Any questions so far? If you may put it back up there. You may put it back up there. Ever done? Again, you don't have to write all this stuff down because it's all going to be online anyway. So, and all right, let me give you some numbers. And I want you to put them on a number line. Actually, I should put this. When in math, whenever you see squiggle lines at the beginning and end, this is called the set of numbers. Those squiggly lines represent a set of numbers that we're using. So let's put these on a number line. Let's try 2 ways. Let's do it once without getting common denominator, and then we'll get common denominator and see if we're right. So what number is farthest to the left, you think? Whatever it is has to be negative. So it's got to be one of these first two. which one's smaller? Remember, when you have decimals, the bigger the number, the smaller, and it's negative, the smaller it is, because it's further to the right. So which one of these two are bigger? Right, because this is greater than 1. This is negative 1 1/2. This is less than 1. So negative 1 1/2. There's our first one. Negative 3/2. Negative 2/3, since it's less than 1, that means we break up this first one into thirds. 1, 2, 3. So this is 1/3, 2/3, and that's 1. This is negative 1/3, negative 2/3, negative 3/3. Our number is negative 2/3, so it's there. That's negative 2/3. The next one is 1/2. That's between halfway between 0 and 1. It's positive to the right. The next one, 1 1/3. It's bigger than 1. It's 1/3 bigger than 1. Again, we split these up into 3 parts. So this is 1 1/3. 23/8. How many times does 8 go into 23? 2 times. With how many left over? Very good. So it's 2 7/8. So it's bigger than 2, and it's just smaller than 3. We divide this into 8 pieces. So 2 7/8 is right before the 3. Three 1/4. It's bigger than 3. It's 1/4 bigger than 3. So we cut this into 4 parts. And right here is 3 1/4. What's another way we could have done it? Fortunately, these were given to us in an order already. How else could we have done it to make sure if these were all mixed up? So let me mix them up. Now, this was mixed up. If I gave you a bunch of numbers like this, how would you have put them in order? Because here we're talking about numbers that are larger than, less than, and larger than inequalities. So how would you do? I see you guys writing? What's your procedure? How will you do this? And we have to compare. The only way to compare numbers is to compare the bottom. If the bottom numbers are the same, then all we have to do is look at the top numbers. since 1 is less than 3. So in other words, whenever you have fractions, you have to get a common denominator. So to compare fractions, you need common denominators. And simply compare the numerators. So to compare fractions, you have to have them all written down in the same denominator. Once you do that, then you just look at the top numbers, and it's in that order, the smaller to larger. To compare fractions, you need common denominators. Once you have that, then you simply compare the numerators. So you see the problem with our list of numbers? What denominators do we have so far? We have 3, we have 2, we have 4, and we have 8. So using this chart, what do we need to do next? Very good, very good. Factor them. Prime factorization, very good. 3 is a prime number, so you're done there. 2 is a prime number, you're done there. 4 is made up of 2 times 2. 8 is made up of 4 times 2, and 4 is 2 times 2, so it's 2 times 2 times 2. Now let's figure out what we need to make them all equal. So this one has a 3. None of these other ones have a 3. So they all need 1 3. Now all of them have 1 3. This one has a 2. This one doesn't, so it needs a 2. This one has 2 of them. This one has 3 of them. So, so he has 2 2s. So he needs another one. And he needs another one. This one already has 2 2s. It's got 3 2s. So he needs 1 more 2. He needs 1 more 2. And he needs 1 more 2. They all have to have the same number of numbers. So I have 2 2 2 3. 2 2 2 3. 2 2 2 3. 2 2 2 3. So they all have to have the same numbers. If we multiply them together, we get 3 times 2 is 6, times 2 is 12, times 2 is 24. So 24 is our LCD. So far, so good? Or if you don't have to use a chart, you can use whatever method you want to. But that's what your objective is, to get the LCD. Now I'm going to use these numbers here to tell me what I multiply to the top. 2 times 2 times 2 is 8. So for the number that has a denominator 3, write these numbers down. I want to first convert them all into fractions. 3 times 1 is 3, plus 1 is 4, so it's 4/3. This is already a fraction. This is a fraction. 3 times 4 is 12, plus 1 is 13. Okay, so I just changed each of these so that I have one denominator. Now, what this method does is any denominator that has a 3, we multiply 8 to the top. Any denominator that's 3, we multiply 8 to the top. So that one has a 3. So I multiply 8 to the top. 8 to the top. 8 to the top. Any denominator that's a 2, I multiply 3 times 2 is 6. I multiply by 12. If the denominator is 2, I multiply the top number by 12. Oh, that's an 8. What am I doing there? That's an 8. It's not a 3. Any denominator that's a 4, I multiply the top by 6. And if the denominator is 8, I multiply by 3. This one here. Why do I multiply only the top? Because I already know my bottom number. That's my LCD. I know all the bottom numbers are going to be that. So I don't have to worry about the bottom. All I got to do is worry about the top. 4 times 8, 32. 12 times 1, 12. 8 times 2, 16. 13 times 6 is 78. 3 times 12, 36. 23 times 3, 69. Now I can compare the numbers. Only look at the top numbers so you can see which one's bigger than the other one. So the smallest number we have is negative 36. The next negative number is negative 16. And of the positive numbers, the smallest number is 12. 12 or 24. Then 32. Then 69. And then lastly, so there they are in increasing order. Everybody follow me what I did so far. Once you get the common denominator, fix the top numbers, and then I can just compare the top numbers only. Now, the computer wanted you to put these answers in because it's not what they gave you. You have to write those numbers back down or simplify each one of these. 36 over 24, that's this one. That one came from negative 3 over 2. The negative 16 is the third one. That's negative 2 over 3. 12/2 came from 1/2. 32 came from 4/3. 69 came from 23/8. And the 78 is from and then this one was 1 1/3. That one left alone. And that one was 3 1/4. So that's how you compare numbers. If you're given fractions, get a common denominator with all the fractions. When we write equations and numbers, we use something called set builder notation. This defines what your variables are in your equation. For example, if my equation was 1/x, what's the only rule we know about the fractions? What can you not have on the bottom? You cannot have a 0 in the bottom. So the only restriction we have here is x cannot equal 0. So how would I write this in the set builder notation? This symbol here says the set of, in this case, x, that line there means such that and you have some sort of condition. This is set builder notation. It's read the set of x such that here's a condition. This tells me all x's I can use. Because all it does here, it defines what x can be. So basically, that's called the domain. Whenever you hear the word domain in mathematics, that's the description of what x's you can use. So in my math equation up here, how would I put the restriction? What x's can I use in this equation? What x's can I use in this equation? I can use all x's except. That tells you what you can't use. X cannot equal 0. This means cannot equal, or does not, or is not. Using set notation, I would say the set of all x's such that x is not equal to 0. That's how I write it. When you read this, you know that all your x's are possible except for this one. Give me some examples of what I can have here in this statement. In other words, my set, give me some examples of what my answer set could look like. How would you read this? The set of m's such that m is a member of the even integers. But mathematics is a language. That's symbolic language. The set of m such that m are even integers. So what are some examples of even integers? What's missing? You have negatives, you have positives. You can put 0 in there. 0 is what separates the integers from the whole numbers. Because the whole number start at 0, go to positive, integers go both directions. So here's an example. Since it says even integers, what's an integer? Integers are positive, negative, and 0. Positive numbers, negative numbers, and zeros. So they have to be even, which means they have to be divisible by 2. So there's my answer. It's all the even integers in the negative, in the positive, and 0. All right. Let's now define these numbers. -5, -2/3, 0, 0.6 bar, radical 2, 3 1/4, 5, and 5.8. All right. Tell me which ones are natural numbers, whole numbers, integers, rational numbers, and irrational numbers. So from that list, tell me which ones are natural, whole, integers, rational, and irrational numbers. So which ones are natural numbers? What is a natural number? Counting numbers. So which one of these are counting numbers? Only one is 5, correct. These are the counting numbers. Which ones are whole numbers? Whole numbers are counting numbers plus the 0. So there's 0 and 5. What are which ones of these are integers? -5, 0, and 5. Because the integers are the whole numbers plus the negative numbers. How about rationals? Integers are positive numbers. Negative numbers and 0. Which ones are rationals? Let's start from the left. Is -5 a rational? Yes. Because it can be written as -5/1. Is -2/3 a rational? Yes. Is 0 a rational? Yes. You can put a 1 underneath it. It's still going to be 0. It's irrational. Is 0.666666, is that a rational number? Yes, because rational numbers, if they have decimals, they're either terminating or repeating. So that one's repeating, so it's a rational number. Radical 2. If you put that in your calculator, it will not have a pattern, neither will it end. So it's an irrational number. Three 1/4, 5, 5/1, and 5.8 is the same thing as 58 divided by 10. It can be written as a fraction. So, any questions thus far? Yes. Whenever you have a decimal, let's say, and it goes out that way forever, instead of writing that forever, you would, if you had a set of numbers that always repeated, and you can tell me what the next two are going to be, then I would put that bar over those two numbers. So whatever is under the bar is the repeating pattern. What do you think the additive inverse is? Or first off, what does inverse mean? Opposite. Inverse means opposite. You were right. Yes, it is a flip, but it doesn't mean the inverse itself. It works only in multiplications, the flipping part. So inverse simply means opposite. Additive inverse. What is the additive inverse of 3? What's the opposite of 3? Yeah, -3, because if you add them together, you get 0. What's the additive inverse of -5? +5. Because when you add them together, it has to equal 0. What's the additive inverse of -3? How does it become 3? Why does it become 3? Let's see. What's the additive inverse of 4? -4 has to have opposite signs. Here's a number. Here's the inverse. The additive inverse, I should say. Basically, all you did was put a negative in front of it. You do the same thing. If I gave you a -3, well, you'd put a negative in front of it. Negative times negative is positive, so that's the reason it becomes positive. That becomes the double negative becomes +3. The opposite inverse of -3 is +3. So far, so good. Why? When will we use this? Why would we learn something like this? When we're solving. When we're solving, is this an expression or an equation? What's that called? Equal, so it's equation. If it has an equal sign, it's an equation. What do you do with equations? You solve. So when you solve, you have to get the variable by itself. To get the x by itself, what do you have to get rid of? The +4. What's the opposite of +4? -4. Whatever you do to one side, you got to do to the other. 7 minus 4 is 3. That's why we learn this kind of stuff. Because we're going to put it together with other rules. Now we're going to start solving things. So that's what the additive inverse is. Remember, the whole purpose of the inverse is to get rid of the number. If we have 3, we add -3, we got rid of the number. We had -5, we added the opposite to it, they got rid of it. So it's basically the opposite is to get rid of that single number. Does it only work with numbers? how do we get rid of the y? I want to get x by itself. How do I get rid of the y? How is y connected to x? It's adding. What's opposite of adding? Subtracting. Subtract what? The y. Do it to both sides. So the y's are opposites, they cancel. And minus y. So it works no matter what you have. I know you've heard it. What is an absolute value? What does it do? Yes. Makes the number inside and I'm glad you said the number inside. So the absolute value of 3 is 3. The absolute value of -4 is 4. The absolute value of -5 is no. Well, yes, it's not 5, it's negative. Yes, it's -5. Order of operations. What do you have to do first? Special operations. So what is the absolute value of -5? Yeah, this one stays there. So it becomes 5. So that becomes 5. So it's now the answer is -5. It only changes what's inside the operation. What's that going to equal? 4? How'd you get 4? It's 5 and a 2. Yeah. So yeah, you have to first do inside the operation. 5, since they're opposite signs, 5 is bigger, so the answer is positive. 5 minus 2 is 3. Absolute value of 3 is 3. Because remember, it's an absolute value. You cannot take it on an equation. You have to work out the equation. Once you get a value, a single number, then you can do the absolute value. What's the answer? Yeah, it doesn't matter all these signs and everything. It's inside the absolute values. No matter what it's going to be X. All these signs doesn't matter. But if you want to work it out, negative times negative is they cancel. Negative times negative is they cancel. So what I really have is this. And it doesn't matter if it's positive or negative, it's just what's inside there. So basically, absolute value is the distance from the number inside to 0. The absolute value is nothing more than the distance of whatever number you have inside there to 0. -3 is right there. How far is -3 from 0? 1, 2, 3. So the answer is 3. That's 25. So go to 5. How far is 5 from 0? 1, 2, it's 5. So it's simply the distance from that number to 0. And can you have a negative distance? No. Because if you live in Irving, you drive to Dallas or drive to Fort Worth, you don't say, okay, if here's Irving, here's Dallas, and here's Fort Worth. You don't say Dallas is -23 miles away because it's to the left of Irving. No, you simply say it's 23 miles away. Fort Worth is 18 miles away. So whenever you talk about distances, you never talk about negative numbers because you cannot have a negative distance. So far, so good. So absolute values are simply the distance from the number inside the symbols to 0, how far that it sits. All right, that's the end of section 3. Next section. Well, we're likely going to go through sections 4, 5, and 6, just to go over the basic rules again. So what are the rules about addition? The only real rule we have here, if the signs are the same, then use the common sign and add the numbers. That's the only thing we say about addition. Four plus 5. They're both positive, therefore the answer is going to be positive. 4 plus 5 is 9. -3 minus 8. They're both the same signs. They're both negative. The answer is negative. 8 plus 3 is 11. So we've been doing that for 6 weeks now. The only thing we haven't talked about word problems. So when you hear the word addition or add, what words mean addition? Sum, not S-O-M-E, S-U-M. That means addition. What's another word? Very good. What else? Increase or increase by. If the current price of gasoline is $3 and it increases by 10 cents, what is it now? 3.10 because you added them. What other words do we know that mean plus? Word plus means plus. More than. Raised. Advanced or advance. We need more words. I mean, this list should be about 10 words longer. But it all has one thing in common. Each one of these words means an incremental increase or movement in a positive direction. The number of students awake is 4 more than it was yesterday, which was 9. So what is the new number? Yeah, yesterday it was 9. There are 4 more, so there's 13 students that are awake. In reality, we should only have word problems as examples in math. Because think about it. When I read you a math problem, if I read you this, how would you hear it? If I read you this, how would you read it? What would you hear? Yeah. 9 plus 4 equals 13. Everything that you learn is always in words. If I say the word 7, you take that seven, the word seven, and you make it mean that symbol seven. So we should only teach math in word problems. Subtraction. This is section 5. If the signs are different, then take the sign of the larger number and subtract the two numbers. Larger minus smaller. Five minus 2. The different signs, as soon as a positive, that's a negative. Since 5 is bigger, the answer is going to be positive. 5 minus 2 is 3. Negative 4 plus 8. Again, they're different signs. Since 8 is bigger, it's positive. The answer is positive. 8 minus 4 is 4. Which one where? Like this? Right here? Yes, because with this, good question. I was gonna get to that in the next section, but yes, this will work. Yeah, we have negative 4. Whenever you put a negative out in front of it, what this really means is I have what numbers in front of here? I have negative 1 times negative 4. So negative times negative is a positive. 1 times 4 is 4. So yes, if you put a negative in front of a negative number, or put a negative in front of it, it becomes positive 3. Yes. What words mean subtraction? Difference? What else? Minus. Less than. What's that? Yes, yes, very good. What else? Subtract. It was, we did that already. Or we say lower. Let's try to figure out one more word. That means subtract. Think of business. If you went to the fair and you had $100 and you lost 80, how much do you have left? 20. So you subtract. Yeah. Yes, somebody told me it's like $20 just to get in, $25 to get in. 24. But here's the thing about it is you spend $24 to go inside there to do what? Spend more. Eating and writing but a lot of this stuff goes to good causes. So there's the words we have for subtraction. And again, anything that means negative is subtraction. All right, so the next one we have is section 6. That deals with multiplication division. Multiplication and division. The inverse of multiplication is division. Remember, inverse means the opposite. So the inverse of 2/3 is what's the inverse of 2/3? 3/2. These are called reciprocals or flips. The inverse of multiplication is division or the reciprocal. Because now, how do you know they're inverse of each other? If you multiply them, they always equal 1. What's the rule for multiplying fractions? When you multiply fractions, what do you do first? That's adding, subtracting. No. The first thing when you're multiplying fractions, first, reduce. Can anything, any number on top cancel with any number on the bottom? Can any number on top cancel with any number down here? Yeah, the 2 goes into 2 once. The 3 goes into 3 once. So we have 1 times 1 is 1. 1 times 1 is 1. 1 divided by 1 is 1. Once you reduce as far as you can, multiply top by top and multiply bottom by bottom. Never multiply straight across first, because you're gonna make the numbers super large and it just won't be any fun. So when you multiply fractions, How about if I gave you -3/7? What's its inverse? Go to it. Yes. Yeah. Just take what you have here. So the opposite of this is -7/3. Take what you have and flip it. If you multiply these two numbers together, the 3's cancel, the 7's cancel. So I have -1 times negative times negative is a positive. 1 times 1. 1 times 1 is 1, which is, this is how you know you have an inverse. What if I gave you a fraction like this? I know, it looks weird, doesn't it? This, whenever you have a fraction over a fraction, take the top fraction, leave it alone. Take the top fraction. Change the division to multiplication and flip the bottom. Now, can anything on top cancel with anything on the bottom? Listen. Yeah, the 3 goes into 3 once. 3 goes into 15 5 times. Nothing else. So we have 1 times 9 on top. 5 times 5 on the bottom. We know 9/25. That's as far as we can go, because if we can cancel it, we would have done it here or here. That's why you always cancel before you multiply. So there are 3 ways you can have division. There are 3 ways division can be written. Like that. Like that. Like that. Actually, that's not. So we have the denominator and the A is always numerator. So no matter which way, remember, these could be numbers. So all A and B could be numbers. 3 goes into 9 3 times. 3 times 3 is 9, 0. So there's your answer, equals 3. 9 divided by 3 is 3. 9 divided by 3 is 3. These can also be fractions. Was A earlier? 15/9. If it's given to you this way, it means the same thing as this one. Because whatever's out here is your denominator. Whatever's in here is numerator. Let's look at all three of these ways. First off, if you were given this method, rewrite it somewhere else. This is not fun doing this method in fractions. If you're given in this way, it's called a compound fraction, a fraction within a fraction. Rewrite it this way. The top number, here's your division symbol, and the bottom number. We can't do anything because of this sign. Change the division to multiplication and flip the bottom or the second number. And then go on from there. 3 goes into 15 5 times. 5 times 5 is 25. 9 times 1 is 9. All right, let's go take a break for a little bit, and then we'll come back. We'll finish up the chapter. All right. Section 7. Has to deal with the properties of math. The order of operation tells us when to do something. The properties tell us what we can do. The first property. The commutative property of. The commutative property of. To commute means to move. We have two of them. The commutative property of addition what this one says is if I have two numbers and I add them together, it doesn't matter which order I add them, it'll give me the same answer. For example, 4 plus 5 is the same thing as 5 plus 4. It doesn't matter the arrangement of the numbers. They're both going to give us 9. So that's the associative property of addition. The second property is the commutative property of multiplication. Again, it doesn't matter the order in which the numbers are multiplied together, they'll give us the same answer. Four times 5 is the same thing as 5 times 4. 4 times 5 is 20. 5 times 4 is 20. Again, doesn't matter how you arrange them. So the commutative property gives us the ability to move numbers around. All right. The second property is called the associative property of. The associative property deals with grouping. The associative property deals with grouping, associating numbers together or groups of numbers together. Can you tell me why the order of operations has parentheses in there? What do parentheses tell us to do? But why? I mean, if we know that we're supposed to do multiplication for division, and well, let's talk about that. Let's look at that. First one, the associative property of addition. Says this. If I had, let's say, 3 or more numbers, and I add them all together, x plus y plus z is the same thing of x plus y plus z. True? But the problem with our brains or anything, any computer systems, we can only do 2 numbers at a time. So what 2 numbers do we do first? Well, that's where the parentheses come in. If you have a series of numbers and they all have the same sign between them, then it doesn't matter how we group them, arrange them, we can get the same answer. 3 plus 4 plus 5 is equal to 3 plus 4 plus 5. So as long as the operations are all the same, they're all pluses, I can combine them how I want to. And since we can only do 2 numbers at a time, I group what numbers I want to do first. So in this first one, 3 plus 4 is 7. 7 plus 5, 12. On the other side, we have to do inside the parentheses first. So it's 4 plus 5 is 9. 3 plus 9 is 12. The same thing is true with the associative property of multiplication. It says x times y times z is equal to x times y times z. So I pair the first 2 and I pair the last 2. Three times 4 times 5. On the left side, we have to do inside the parentheses first. 3 times 4 is 12 times 5. On the other side, 4 times 5 is 20. $12 times 5 or 3 times 20. Which side is easier to do? Yeah, 3 times 20 is a lot easier because 3 times 2 is 6 with a 0 behind it. No movement of the numbers. 12 times 5, yes, you can do it. But at first do 5 times 2 is 10, carry the 1. 5 times 1 is 5, plus 1 is 6. A lot of moving parts. So there you have the beauty of the associative property. We could arrange the numbers or group the numbers as we want to make it easier for us. So the commutative property says we can move them around. The associative property says we can group them however we want to. But you notice in the first two properties, we've separated multiplication and addition. The third property is probably the most important one you'll learn. It's called the distributive property. The distributive property takes both the addition and multiplication and puts them on the same equation. Distributive property. So you see you have multiplication and you have addition and parentheses. So this rule combines everything. Anything in front of a parenthesis or in front of a variable is called a what? What is this number in front called? It's called a coefficient. A coefficient is any number in front of a parenthesis or in front of a variable. The distributive property, again, it combines multiplication, so it's a times x plus y. And it combines multiplication and addition. So what we have to distribute whatever is in front of the parentheses into everything inside the parenthesis. So a times x is ax. Positive times positive is positive. A times y is ay. Now here's the cool part. That's the distributive property. If you go from this direction, from left to right, it's distributive. Take whatever's in front, multiply it, everybody inside the parentheses. Now, if you go from right to left, this is called distributivity. If you go from right to left, that's called factoring. Why is it called factoring? Because what factoring does is, what do these two equations, what do they have in common? Ax plus ay. What do they have in common? They both have the a, so we put the a down. Since that's what they have in common, everything else. So if we take away the x and the a, what do we have left? We took away the a, what do we have left? X plus y. Factoring takes what we have and makes it into smaller equations. And that's what we're going to do in chapters 15 and 16. We're doing this a lot. So one benefit of the distributive property, it gets rid of parentheses. you have parentheses right here. Because if we can't do anything inside the parenthesis, order of operations, do inside the parenthesis first. If we can't do anything, then we have to get rid of the parenthesis. So that way we use distributivity. Negative times positive is negative. 4 times x is 4x. Negative times negative is positive. 4 times 3 is 12. There we have it. Yes. Yes. The what? If it's which in the front positive? Like that? Oh, how we ended up? Oh, I'm going to just. So again, when you first do separate the signs, what's the sign of x? Is it positive or negative? It's positive. So negative times positive is negative. 4 times x. Negative times negative is a positive. Then 4 times 3. So I build it up going this way. Like the negative times a positive is negative. 4 times x is 4x. Negative times a positive is a negative. 4 times 3 is 12. All right, 2 more properties. The fourth. The identity property of addition. The identity property is what do we have to combine with this number so it keeps its identity? It doesn't change what it is. So x plus what gives me x? Or 3 plus what gives me 3? 0. So the additive identity is 0. Because if you add 0 to something or subtract 0 from something, it doesn't change the number. How about multiplication? The identity property of multiplication. What times x gives me x? 1. Yeah. 4 times 1 gives me 4. Okay, now, have we ever done this before? Talk about multiplying by 1. When we talk about fractions, if I had 3/5 plus 1/3, you can't add them until you have a common denominator. So what do you multiply to the first one? What's the common denominator? So what times 5 gives me 15? 3. 3 over 3. Whatever you do to the top, you have to do to the bottom. What times 3 is 15? But what is 3 divided by 3? 1. That's this rule. I'm multiplying by 1 I'm not changing the number, I'm simply changing the way it looks. So 15's on 5 times 3 is on the bottom, 3 times 3 is 9. 5 times 1 is 5. 9 over 15 is the same thing as 3 over 5. If you simplify it, 5 over 15 is the same thing as 1 over 3. And then you add the two numbers. So that's the idea. We've been using this all along whenever you combine fractions. Now the inverse function, inverse property. So the identity property is leave the same. That's what the identity property is. What do I have to multiply or add to so it doesn't change the number? The inverse property we're trying to eliminate. It's the opposite. So we're trying to get rid of it. So x plus what gives me 0? What's the opposite of x? Negative x. Negative 5 plus what gives me 0? 5. 3 plus what gives me 0? Negative 3. So the inverse property is simply adding the opposite to it. And the multiplication rule. What times x gives me 1? Because remember, this is a fraction, x over 1. To get rid of something by multiplication, you have to reciprocate it. So the opposite of x is 1 over x. Or the opposite of a over b is b over a. It's the reciprocal. That's what's the opposite in multiplication. So what times 4 gives me 1? Yeah, this is 4 over 1, so it's 1 over 4. Two-thirds times what gives me 1? Yeah, 3 over 2, the flip of it. Let me get some examples here. Oop, nope, 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 nope. I want that one back. Oh well. Use the properties we just talked about and simplify this equation. or work it out. 25 times 69 times 4. Again, at this level of math, you should never use calculators at this level of math. Because if you get the two dependent on calculators at this level, then upper levels are going to kill you. So do we know any properties we can use here that'll help us? You should be finished by now. I'll show you why. What if we rewrote these numbers in this order? What's 25 times 4? 100. 100 times 69 is 69 with 2 zeros behind it. It shouldn't be a lot of work. That's the reason we learned these rules, is so we can move numbers around to make life easier for us. Okay, so now since we talked about moving things around, how can you move these numbers around to make them easier for you? Can we see two numbers that'll help us here real quick? 41 and 9. If we put those two together, is that going to be pretty easy? What other pair of numbers can we put together? 23 and 2, right? Because 23 and 2 gives us 25. So 51 plus 49 is, or 41 plus 9 is 50. 23 plus 2 is 25. 25 plus 25 is 50. 50 plus 50 is 100. This is why calculators are not necessary. If you look at the numbers, move them around, do the easy ones, you could do everything in pencil and paper. All right, those are the properties, and this is why we use them, how we can use them. That's end of section 7. Section 8 deals with simplifying expressions. Remember, what's an expression? What's an expression? Very good. Does not have an equal sign. You only simplify these. You don't solve. You simplify by combining like terms. What's a term? Very good. Excellent. Any number separated by plus, minus, or equals. Work this one out, or simplify this one. When you hear the word simplify, you know that there's no equal sign in there. It doesn't have to equal anything. It's just going to be simplified, combine like terms. Again, here, we're going to use the distributive property. Since there's nothing else, we can't do anything inside the parentheses. So let's get rid of the parentheses. Positive times positive is positive. 4 times 3 is 12x. Positive times negative is negative. 4 times 2 is 8. Y. As far as we can go. We can't combine these two, but that's X and Y. Apples and oranges. Can you combine these? If so, why? It's what? They both have a Y. What's the final answer? Yeah, because of the order by the commutative property of multiplication, I can rewrite these two as XY. You can move them around anyhow you want to. So now they're both XYs. I take out the XY. What I have left is 3 plus 4. Remember we talked about factoring? They both have an XY in common, so I take it out. What I have left is 3 plus 4. 3 plus 4 is 7. XY. How about this one? So what do you do first? Since you can't do inside the parenthesis, order of operations, you have to get rid of the parenthesis. Positive times positive is positive. 3 times 4 is 12. Okay. Positive times positive is positive. 3 times 5 is 15. Once you get rid of parentheses, always combine like terms. 6 plus 15 is 21 plus 12K. We'd put our answer as like this, 20. Always put the variables to the left and the constant numbers to the right. All right, let's try another one. First thing we gotta do is what? Yeah, because we can't do anything inside the parentheses, so we have to distribute. So negative times positive is negative. 3 times 2 is 6. Negative times negative is a positive. 3 times 5 is 15K. No more parentheses, so we combine like terms. Start with the letters first. 9K plus 15K. So 9 plus 15 is 24K. They're both negatives. 6 plus 6 is 12. And there's your answer. What do y'all think? We've done this stuff since day 3 or week 2, pretty much. You just have to follow all the rules of math. All right. So that does it for chapter 11. We'll call it a day there.